Okay guys, I had one of my students ask a question about POTT, permissive overreach transfer trip, on powerline relaying. So today we're going to talk just for a few minutes about pilot protection on transmission lines. I want to give you just a high-level overview, something you can use and take with you, and maybe apply to some of your other classes. The first thing I want to talk about is powerline carrier before we get into the POTT. Powerline carrier and POTT essentially accomplish the same thing. The main difference is that powerline carrier, the communications is on the power line itself. With POTT, the communication is on fiber. So we're going to go through a scenario, put a fault on a line, see how the carrier works, and then we'll do the same scenario with POTT and see how they're similar and also how they're different. So the way that I'm going to set this up, some companies are different. The company that I work for, Zone 3 on the relays, look in the reverse direction. A lot of companies in Zone 3 look in the forward direction, but we're going to go through it today with the Zone 3 looking in the reverse direction. Okay, so let's set this up. We've got breakers and transmission lines. Let's put a dotted line around this group of breakers because this would represent a substation and this would represent a substation. Okay, now Zone 1 is going to look out 90% of the transmission line, forward looking. Zone 2 is going to look around 120% of the transmission line. So it's looking, Zone 2 from this breaker is looking the entire length of this transmission line through the bus 20% into the next line. 120%. Zone 3 is looking in the reverse direction 300% or 3 line segments is a good rule of thumb. And by looking back that far, you would know that if you truly got a Zone 3 operation, that it would be a huge deal, and it would be a widespread area outage. There's things that are implemented that we won't discuss right now, but such as bus breakups or bus backups that should operate to minimize the impact before you would have a Zone 3 operation. So this breaker will do the same thing. Zone 1, 90% of the line. Zone 2, 120%. And Zone 3, reverse looking 300%. Okay, so now we're set up, but now this breaker, keep in mind, this breaker is the same thing. These breakers are going to be looking the same way, same setup. They've got the Zone 1, Zone 2, Zone 3 the same way. So let's put a fault on this line, right here. This breaker 1, we'll call this breaker 1, we'll call this one breaker 2. Breaker 1 here, Zone 1 is going to see it. It's going to trip high speed. Zone 1, instantaneous trip. Okay, this breaker is just outside of this breaker Zone 1. So these Zone 2 relays are going to see it. Now Zone 2 tends to be about 20 cycles as opposed to an instantaneous high speed trip. But we know the fault's in the primary line segment, so we don't want to wait 20 cycles to clear the fault. We want it to trip instantaneous. So how do we accomplish this? Well, this breaker, Zone 3, is looking back. Okay, this breaker number 1, Zone 3, does not see this fault reverse looking. So it does not send carrier blocking. So because this breaker is not receiving the communication blocking signal from this breaker, Zone 2, it makes that Zone 2 instantaneous. So because this one does not see the fault, it does not send a blocking signal to Zone 2, which makes the Zone 2 an instantaneous trip. So you're probably thoroughly confused, so let's do this. Okay, let's put the fault here. If we put the fault here, this breaker is still going to see the fault. But the Zone 3 from this breaker also sees it because it's reverse looking. Breaker 1, Zone 3 is seeing that, so it knows it's reverse looking. So it's sending a carrier blocking signal back to breaker 2, and it's saying, hold on, wait, it's not in the primary line segment. I see it reverse looking. So it's sending a blocking signal. So instead of zone 2 tripping instantaneously, now because you're getting a blocking signal because breaker number 1 sees it reverse looking, that blocking signal is going to make breaker 2, zone 2, trip in 20 cycles as opposed to tripping instantaneous. Okay, so that's how carrier works. So let's go through it one more time. Okay, we'll put the fault here this time. Breaker 2, zone 1 sees the fault. Instantaneous trip. Breaker 1, zone 2 sees it. Forward looking. Zone 1 doesn't see it. Zone 2 sees it. Forward looking. Zone 3 from breaker 2, this one right here. Zone 3 does not see the fault in the reverse direction, therefore does not send a blocking signal to breaker number 1, and lets breaker number 1 trip zone 2 instantaneous. No time, no 20 cycles, high speed trip. So that's how pilot protection gives us, the primary purpose is to give us high speed tripping on 100% of the line. You need to remember that. All you system operators out there need to remember that. If you're in exams or interviewing for a job or sitting on the desk trying to troubleshoot a fault, pilot protection gives us high speed tripping on 100% of the line. So your question probably is, well, why not make zone 1 look 100% of the line? And that's a great question. And it would be a great theory, but in actuality, there's no way that you can tune the relays to be that precise. So you set zone 1 to look at 90% of the line, and then you have the pilot protection that communicates, the relays communicate back and forth, and that allows you to decipher where the fault is and should it trip or should it not. Okay, so that's power line carrier. Now, let's take a look at POTT. Same principle, just a little bit different in operation. And we're going to make this just a little more simple on the board here, not jumble it up as much. Okay, we got breaker 1, breaker 2. Very, very same principle. Okay, zone 1, 90%. Zone 2, 120%. Zone 3, reverse looking 300. Zone 3. Zone 1, 90%. Zone 2, 120%. Okay, same thing here. Zone 1, 90. Zone 2, 120. Zone 3, reverse looking 300%. Okay, so let's talk about how POTT works. POTT standing for Permissive Overreach Transfer Trip. Okay, so now let's put a fault on the line. Breaker 1 sees it forward looking. Okay, breaker 2 also sees it forward looking. The way POTT works is it kind of works like an AND and OR logic. Okay, so let's draw an AND gate. Okay, so the output's going to be a trip. So we got input 1 and input 2. So this is looking for a 2 out of 2 logic in order to trip. And the 2 out of 2 logic it's looking for is both of these breakers to see the fault forward looking. Okay, so the fault being right here, breaker 1 sees it forward looking. Breaker 2 sees it forward looking. So that makes input 1 high, input 2 high, gives us the output high speed trip on both ends of the line. Okay, so now let's put the fault outside of the line. We'll make another one here. We'll call it 3 and 4. We'll put the fault here. This breaker sees it. This breaker sees it forward looking. Okay, so it sees it. Breaker 2 sees it forward looking. It's got a high input. Breaker 1 does not see it forward looking, it sees it reverse looking. And because this breaker does not see it forward looking, it does not have an input. It's 0. So you got a 1 and a 0, and because this is an AND gate, you do not have a trip. Your output is 0. Okay? But then if you look at this line, this breaker is going to see it forward looking. This breaker is going to see it forward looking. So both of these breakers are going to trip high speed. And then this breaker should never operate unless one of these breakers fails to clear the fault. If one of these breakers fails to clear the fault, then zone 2 would trip in 20 cycles on a time trip. So that's how POTT works in comparison to how carrier works. They both accomplish the same thing. Again, high-speed tripping on 100% of the transmission line. We accomplish the same thing. They work different. Most of the new installations that I have personally seen are using POTT as opposed to powerline carrier. One of the big ways that you can tell is that a powerline carrier is going to have, because it's on the line, if you were looking on a single line diagram, you would see something like this coming into the breaker. Some kind of inductance sign, on the line coming into the substation representing a wave trap. And what wave trap does is, because the communications is on that transmission line itself, it's a frequency filter that keeps the communications on the transmission line. So you'll see the power line wave trap. You would might see a carrier ground relay that would let you know that it's power line carrier. And POTT, you're probably not going to see a wave trap. You would probably see a CCVT on the line, so you would see some kind of capacitive device, something like that, and you might see a DPU, like a digital processing unit, that sent communications back on fiber between substation 1 and substation 2. So those are some of the differences that you might see on a dispatcher single line, if you were looking to differentiate if you had power line carrier or if you had POTT. There are some differences in them as opposed to transmission line switching. Some things that carrier would impact your switching as opposed to that POTT might not. We will cover those at a later date if you have any kind of questions about those. But this is a basic overview of how pilot protection works on the transmission line. I hope you find it beneficial. Always shoot me an email, ask me some questions. If you got anything that you'd like to know more about, I'd be glad to help you with it. Thank you.